Welcome to a geometry video for skill number 52. I can use ratios to make indirect measurement and use scale drawings to solve problems. Alright, this skill breaks down into two pieces, using indirect measurement and then finding the perimeter and area of similar shapes. The first thing we should know is what indirect measurement is, and that's basically a measurement that you make indirectly. So rather than slapping a ruler down against a building and measuring how tall a building is, you use some other method, and that's usually done with similar shapes or proportions or formulas. We're going to focus on looking at similar figures and using those similar figures and their proportions to measure the object. So here we got example 1. It says Tyler wants to find the height of a telephone pole, and the pole shadow measures 38'4". So if we have a telephone pole over here, let's just add some color to this. Our telephone pole looks something like that, and the shadow of the telephone pole is 38'4". Tyler's own shadow is 7'8", and Tyler stands 5'9" tall. And what we're looking for is how tall is the telephone pole. And we can actually relate this to problems that we've done before, where what we have is similar triangles. These are both right angles, and then the angle that the shadow makes is the same, so we can say the triangles are similar. Since we have complex units, or basically a unit that is feet and inches, before I did anything I converted everything to inches. And then I set up the proportion, and I have a proportion 69 inches to 93 inches is equal to x inches to 456 inches. From there we can solve. So 69 to 93 is equal to x to 456. And we can do the cross multiplication and do 69 times 456 gives us, these two multiplied together gives us 31,464, and we set that equal to 93 times x. From there we can divide both sides by 93, and we get an answer of, let's see, 3164 divided by 93 is approximately 338 inches. If we wanted to find out how many feet that is, we can divide that answer by 12, and we get 28 feet and, I don't know, maybe 1 or 2 inches. 28 feet, 2 inches, approximately. So each of the examples I use on this skill, or on this video notes, closely resembles one of the skill test questions. Example 2, a scale drawing for a house uses a scale of 1 inch to 8 feet, and the master bedroom is 1.75 inches by 2.25 inches, on the scale drawing, of course. And we need to find the total area of the room. So what we should do is set up the ratio so we find out how big the room actually is. And we know 1 inch is equal to 8 feet, so 1.75 inches equals x feet. And if we work that out, we find that the room is 14 inches long. And then we set up the same ratio, 1 to 8. And as a proportion, 1 inch to 8 feet is equal to 2.25 inches to y feet. And we find that the room is 18 feet wide. So our room is 14 feet by 18 feet. A 14 by 18 foot room gives us 252 square feet. Moving on to the next part of the skill test, we're told that we're given two similar figures with a similarity ratio of A to B. So if I have this triangle which has 1, 1.1, and we'll say 0.5, and a similar triangle that is slightly bigger, we'll say it's double the size, so 2, 2.2, and the side is 1. And we know the triangles are similar because they've got congruent angles. 1, 2, 3, 1, 2, 3. And the proportion is the same. And our similarity ratio of these two triangles is A to B. A to B is equal to 1 to 2. That means the corresponding ratio of perimeters is also A to B. So the perimeter of our first triangle, if we add it up, has a perimeter of 1, 2, 2.6, and the perimeter of our big triangle has a perimeter of 2, 4, 5.2. So A to B, our perimeters 2.6 to 5.2 should equal 1 to 2. And if we do the math, they are the same. The areas, however, have a corresponding area ratio of A squared to B squared. And to demonstrate that, I'm going to look at the next example. All right, so what we have here is two pentagons, pentagon ABCDE and pentagon PQRST. And we are told the perimeter of one pentagon, the larger one, and the area of the larger pentagon. And we're also told a couple dimensions throughout the pentagon. It asks us to find AB, QR, finds the perimeter of the smaller pentagon and the area of the smaller pentagon. So the first thing we should do is find the similarity ratio. And it looks like we have these two sides that are corresponding. So AE corresponds to PT, which means the length of 4 corresponds to 3. So we have a similarity ratio of 4 to 3. That allows us to find multiple things. We can first find AB. So we have 4 to 3 is equal to this distance, AB, to this distance, PQ. So if we take a pen, 4 to 3 is equal to AB to PQ, which is 5. And we cross multiply and get 20 is equal to 3 times AB, or 20/3 is equal to AB. So we now know the length of AB is 20/3, or as a decimal, 6.6 repeating. We can use the same method to find QR, and I'll leave that to you, but we find that QR has the length of 2.625, and now we're left with finding the perimeter. So we're told on the previous page that the perimeter will have the similarity ratio of A to B as well. So since our ratio is 4 to 3, our perimeter ratio should be 4 to 3. So P1 to P2 should also be 4 to 3, which is our perimeter of our first one is 20, and our perimeter of our second one is what's unknown. So we can cross multiply. 4 times P2 equals 3 times 20. 4 P2 equals 60, and we find P2 to be 15. And we're talking inches, so 15 inches. Moving further down to find the area of the pentagon, our similarity ratio is no longer 4 to 3, but instead 4 to 3 squared, or 4 squared to 3 squared. So what we do is we just square the top and bottom, and we get a similarity ratio. We had 4 to 3, but the areas will have a similarity ratio of 4 squared to 3 squared, which is 16 to 9. And the area of figure 1 is 24, and the area of figure 2 is unknown. So 16 to 9 equals 24 to our area. And we cross multiply, giving us a final area of 13.5 square inches. Don't forget your units. As far as this skill goes, I think this very last step that we did is the one that most people will struggle with. So pay close attention to those ones when you're practicing them on the homework. For this skill, there's 3 things we should be able to do. The first being using indirect measurements. The most common way that we're seeing this is a problem where you're told the shadow length of a person. There we go, there's a little person. And the shadow length of some sort of tall object, and you're supposed to find one of those 4 measurements, either shadow lengths or heights of the person, or maybe this is a flagpole, or maybe it's a building. There we go. The next thing we should be able to do is scale drawings, or rather use scale drawings to find measurements. So if this is a scale drawing of a building, and we're told that the scale drawing is 1 inch equals 16 feet, and this building is 2 inches tall, how tall is the building? The building would be 32 inches. And then finally, we need to be able to do proportional relationships with perimeter and area. So if we had a similarity ratio of, 2 to 3, then the perimeter of the larger figure the perimeter would also have a relationship of 2 to 3. However, the area would have a relationship of 2 squared to 3 squared, or 4 to 9.